So, before we start off on our project, I just wanted to go through our general implementation and algorithm. So, to start off, we sent out a survey and we asked students for their grades. And we have two types of students. We have an upper year student who is a student who has completed at least one or two of the lower level courses, such as COSC 111, COSC 121, Math 100, Math 101, and so on and so forth. And these upper year students have also told us um, what their grades are for the upper year courses, such as COSC 222, Math 200, Physics 216, and so on and so forth. We also have a lower year students, and these are students who have just completed the first basic essential courses such as COS 111, 121. These students haven't taken the upper year courses such as 222 and 200 year courses. But these students have also provided us with their level of interest. That is an extra layer of information. So our project starts off by analyzing this information and storing it in the appropriate data structures. And then for a certain student, we predict their missing grades. So for our prediction algorithm, we implemented a simple collaborative filtering approach. We first start off by getting the cosine similarity between the certain students and all our current upper year students, and we get the weights of how similar a student is to another, and we use that in the collaborative filtering in this formula, and it returns to us the missing grades that the student hasn't taken. So it will return for us the grades for COSC 222, Math 200, Physics 216, and so on and so forth for a certain lower year student. So bear in mind we're only studying, we're performing all of this on lower year students. Upper year students are our database, lower year students are our test data. So the next step of the project is to refine the grades that we got for the certain student. We weren't just going to stop at performing collaborative filtering. We wanted to run through another layer, a BaseNet layer actually, where the certain grade that students would get would depend on other factors. So for our BaseNet, we have four other factors. We have the grade that they get, the major average, the interest they have in the major, and the number of courses they've taken as well, the number of major courses. So these are our observations, and we are trying to predict the hypotheses, which are the final grade and the enjoyability. And we run this layer for every student and for every course that they have taken. So for every student has however many upper year courses, which in our case is five: COS 222, Math 200, Physics 216, and so on. So and we perform inference on that certain BaseNet, and we get certain probabilities that we use. And these probabilities we have defined as the actual results that will tell us how well the student will do, or how interested they are. And after we get the probabilities, our final step is to get the decision. So for our decisions, we've implemented a simple expected utility and decision tree approach. So based on the probabilities we get, we make decision trees, and the decision trees utilities that we have defined are over here, where if you enjoy and do well, you get that's very good utility. That's a 10. Doing bad and enjoying it, or disliking it and doing well, is 0. and deciphering it and doing that is -10. And the utility of not taking the course at all is 5. So our utilities are in the range of -10 and 10. And so after we run through the expected utility layer, we get final decisions that tell us what the student should do. So yeah, that should be the project summed up, and then we just output the decisions and to the students based on their grades. And yeah, I'll now pass it on to Callum to run through a couple of test cases.
Hello, and welcome to our quick 419 final projects demo. So I've already made an example student that we're going to pass through our model. So this student, these are all of his marks and the interest values that they have. So we'll just take a quick look at these marks and see what they all mean. So these first two are in COMP Sci 111 and 121, so he's gotten 85 and 79 respectively. 73 and 68 correspond to, let's find out here, Math 100 to Math 101. And 81 and 83 are physics marks, Physics 111 and Physics 121. And then further on, we have Bio 116 and Bio 125, which they have 74 and 64. And then finally, their physics marks chemistry marks, 111 and 121, which are 53 and 48. So these correspond to the majors that we were just talking about here. So they like comp sci, they really like math, they're okay with physics, not so much bio, and they really don't like chemistry. So we're going to run this object through our GUI and see what happens. So what this is going to do is it's going to find the similarity between this made up students I have here and the rest of the students in our backend. So once it finds some number of similar students and computes the predicted grades for my dummy student, it will tell us if we should take that course or not and what mark we're predicted to have and how much we'll like it. All right, so here we are. This is what you're greeted by when you open up the GUI for our project. And we have two fields that we're going to have to fill in here. So which student are we predicting? That's going to be our video example that I created for us. And then you can choose to ask for a specific course if you don't want to get all the output. So first of all, I'll start off with just showing us what the output could be if we have just the students. So this is our video example, students, and no course requests. So this is going to come up. This will give us everything that we want to know. Since I passed in all of the first year courses, it's just going to give us our upper year courses. So we saw earlier the comp sci marks were respectable, so they're going to get an 80%-ish in 222, and their interest level is fairly high, so they should definitely take this. It's going to be a nice GPA booster. They'll probably enjoy it. Now we go on to Math 200, so they're going to get a 72.6 predicted. That's not quite as high as comp sci, but their interest level is much higher because that's what they put in themselves. So they should probably look at this because with their marks, our model is also agreeing that they do enjoy math. So now we take a look at physics. He didn't do too bad on physics, but he didn't enjoy it. So our model suggested that he would probably get about a 75%. And his interest level is, yeah, it's getting on the lower side, so that's a 59%. So we are saying that they should not take, they should not take Physics 216. And then now we look at Bio 200, which they're also suggested not to take. So they'll get a 65% and they'll really not like it. So there's really no point in them taking it. And finally we come to Chem. We saw their Chem marks, really unimpressive, and they didn't like it at all. So this is agreeing with them. For Chem 201, they would get a 47.6, so 48%-ish, and they would really not enjoy it. That would probably not be a good call for them. So, yeah, if we just wanted to make completely certain that they don't like Chem 201 specifically, we can come up with this. All right, and it's just going to show us Chem 201. Yeah, and it's giving us the same result, of course, because it already queried the model. So, yeah, 48% and low interest level. Now we'll take a look at some other test examples or test cases we had in the documentation. So there's a test case, I believe it was um, test case 1. Okay, so this is when the student has entered absolutely nothing. So they have no interests, no marks, and this is what we get back. So we get back nans and 0%, because the model has nothing to work off of. So it's just telling them, just you shouldn't take anything because you're probably not in a university, this would be the assumption. And now we'll take a look at test case number 2. Comes up right here. This is the overachiever. So they've gotten extremely high marks in every single course, and their interest level they set to 6. So these are the real tryhards, the real go-getters, if you will. So yes, they're getting very high marks in each course, very high interest levels, 100% in fact. That's pretty unrealistic, but I mean, hey, if they get marks, he's good, yeah. And they should take every single course because, of course, they enjoy it and they're going to get a good mark. So our model says, well, why not? And that basically sums up what our system is capable of. Thank you very much for watching. Have a great day.